Okay, this is going to be the first video of my COVID-19 update videos. Today, this video is for honors. This is material we're going to be kind of talking about starting on the 16th. Edgenuity should have given you a little introduction to this, and we'll be continuing to work on this material through the 24th, possibly the 23rd, we'll have to see. But this is going to be a topic on volume. First of all, volume is a measurement of space within a 3D figure. If you recall from the very beginning of the year, we covered surface area. That is a measurement of space outside of a 3D figure. This is the amount of space inside of a 3D figure. Now, there is a similar thing that takes place with volume, which is capacity. Capacity involves a different step. Capacity is when you have the measurement of the space within a 3D figure, but you're trying to measure how many of a specified sized object can another 3D shape hold. So it's slightly different. Volume will always be measured in units cubed. So units cubed is just an amount of units. This could be inches, centimeters, miles, feet, whatever. And cubed is represented with a little 3 exponent by whatever units you're using. A rule of thumb is if a set shape does not tell you the units, you would simply say that it is units cubed. You wouldn't try to guess if it was feet, inches, miles, or anything like that. Capacity is typically going to be a regular number. For example, this could ask how many pens can the package that this Sharpie container hold. That would be a capacity problem. The raw volume, the actual cubic inches inside of the box, wouldn't matter. We would want to know exactly how many of these pens could actually fit. That is capacity versus volume. There is a formula, or rather there are 2 different formulas for finding volume. Volume is equal to the length times the width times the height. Now this is for, very specifically, a rectangular prism. And this has another variation. Or, in a couple of specific situations, volume equals the area of the base times the height. So this is area of the base times height. And this is for the same shape. Both of these are for rectangular prisms. You can use this same formula for finding area or finding volume for a cube, but for cubes, it's more proper to simply write that we are going to take the side length and we are going to find that side cubed. And this is for a cube. The reason cube is simplified is since we can assume that the length, width, and height are all the same, rather than writing out length, width, and height, we're simply going to write s cubed, and we will cube whatever side length that is. So if the cube, for example, has a length, width, and height of, let's say, 6 units, we would simply do 6 to the 3rd power. We wouldn't write out 6 times 6 times 6. It just kind of saves time, saves energy. Now, when I am talking about cubes, one thing that you may be forced to do from time to time is to draw a cube. There are a couple of ways to do that. The way that seems most easy for people, this is not the best way, but if you're drawing a rectangular prism, you are going to draw a standard rectangle at first, and then just diagonal from it, it helps to use this little dotted grid. I'm just going to draw another rectangle, but I'm going to draw it slightly offset. Then you're just going to connect these diagonal lines to each other. Connect, 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 connect. And here you have a rectangular prism that shows all the dimensions. Alternatively, something else you could try when drawing this is the same process, only when you go to draw your outside rectangle, you're actually just going to draw this L shape and connect your corners. Both of these show a rectangular prism. The difference is this shape right here is hiding these invisible lines that are behind the shape. These are not actually visible from the front of the box. Cubes are exactly the same way. And something I should point out, for 6th grade math, North Carolina's Common Standards, we are only going to be dealing with rectangular prisms and cubes. We will not be dealing with triangular prisms or hexagonal prisms or cylinders or cones, any of that, at least not this year. I will put links to material that covers that if you want to work ahead towards 7th grade material. Just know that whenever all of this blows over, we will be actually covering it in class. I should also point out, just you all know what these shapes look like. If you are unfamiliar or don't remember what a rectangular prism, a cube all look like, go back and check. Way back at the beginning of the year, I did make a surface area video that goes over that. But for now, we're going to move on to some example problems. Make sure you remember, or possibly take notes down, on those formulas. Those will be very important. Set this aside, and pull up this little example worksheet. Now, the example is already done, and it already has some stuff down for us. And in the example here, sorry for the noise, just digging out some pens for me to work with, because I don't want anything bleeding over through this page. So, pens ready. One other thing I should point out about this unit is it is calculator active. So you can use a calculator, your phone calculator should suffice, and your Chromebook calculator should also do the trick just fine. You shouldn't really need anything more than that. For number 1, it goes ahead and it gives us, matter of fact, all of these problems, it gives us the length, the width, and the height for every shape. Now, it's not always going to be in the same place. In this case, we have the length here, we have the width up here, and we have the height over here. It won't always be that way, but for the most part, at least with this worksheet, that's the way they've set it up. So, for this, we know that it is 6 2/3 units wide, 5 units tall, and 5 units for the length. Now, my calculator does not do fractions, but here's a little trick you can use to get away with not having to deal with fractions. 6 2/3, if you want to know what 2/3 looks like as a decimal, just do 2/3, 2 divided by 3. And we see that that is 0.6 repeating. That 6 is going to continue to repeat. So to represent 6 2/3 as a decimal, you can trick your calculator into rounding so that way it will equal 2/3. So it is 6 2/3. We're going to do 6, and we're going to just add as many additional 6s as our calculator can handle. So there is our base, or let my width. We have our height and our length, so times 5 times 5 again. And we see here we got an answer, 166.6 repeating. Now we can enter that in for our answer for number 1. We can either enter it as 166.6 repeating units cubed. However, if we think back and remember, oh, 2/3, that was the same as 0.6 repeating, we can go ahead and write it as 166 2/3. And I should have read the directions a bit better. Each prism unit is actually measured in centimeters, so it's not units cubed. I should have read. This is centimeters cubed. And that's how number 1 is done. If you are following along and want to try a few of these on your own, go ahead and pause the video now so that way you can work ahead on these particular problems and see how you do. But otherwise I'm going to keep moving on. Number 2, 6.5, you don't need my help with converting that into a decimal. That is 6.5 times 3 times 5. And that is going to equal 97.5. So we'll write that down. 97.5 centimeters cubed. This is the same as 97.5 centimeters cubed. Number 3, we have 5.5, 5 and 3. So 5.5 times 5 times 3 gives us 82.5. And you might notice this unit is incredibly easy so far. That's only because we haven't gotten into capacity quite yet. For number 3, for example, the entire process of this worksheet would involve drawing, like in this example, drawing each individual section for this. For example, they've got 4 as the height, so they drew and sectioned 4 cubes high, 5 views deep, and then they did 4 1/5. They actually cut this. It's rather hard to see with the light I have, but they actually did sections inside of those cubes. And that's not showing up too well. Oh well. I'll show you what they meant in number 3. For number 3, they wanted sections going as far as 3 tall, so we'll set this up. We need 3 cubes going up, and that wraps around. So there, we have 3 sections. Now we need 5 sections going across this way. So 5 sections going across, so I'm going to need to section this. So there's 1 section, 2, 3, 1, 2, 3, I need to separate 1 more, 4 and 5. I'm also going to draw these lines going straight across. That's a little low. That's okay though. It doesn't have to be perfect. So now for the tricky part, we've got 5.5. So 5.5 sections. I'm going to have 5 full squares, but I'm going to have 1 half square. The easiest way to do that is to draw all of my half sections. So 5.5, if I change this and convert it into halves, I'm going to have 10 halves. 10 over 2, 10 halves. So 10 halves plus 1 half, I should have 11 sections going across. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 lines should mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11 sections. So if I go back over with a darker shade of green, there's 1 hole, there's 2, 3, 4, 5. So I have 5 full-size cubes, but then I have this one little extra sliver on the side. That is my half, to represent 5.5. So we have 1, 2, 3, 4, 5, and this extra half piece over here. That is how this is going to look. So if I were to talk about the capacity, I would actually convert number 3 into halves. So I would take that 82.5 and I would see how many half-size cubes would fit inside. I wouldn't figure out the raw volume there, but I'll be doing something later on capacity. For now, for the rest of this worksheet, number 4, 6 1/5. Again, we're not sure what 1/5 might be as a decimal, so we'll type in 1-5. 0.2. So 6 1/5 would be 6.2 times the height and the length. Gives me 74.4. That is really the entire gist of finding volume. Again, capacity, that will be coming later, probably later on, shortly after I upload this video, but it is easier to record in shorter segments. And that's all for finding volume. I hope that this got you on the right track, and I'll talk to you later.